All right, everyone, happy Tuesday. Hopefully everything yesterday went okay for you with solving the systems of equations. And if you were confused, I really hope you're reaching out to me. Let me know either by email, jump on Zoom. I'm on Zoom every day at 10:30 for you guys. I started that back up again because I know that some of this can be confusing. So you can hop on there if you need help. Just make sure you let me know. And if that time doesn't work for you, let me know some other time. So we're going to continue with systems of equations by substitution today. Today we're going to look at a third scenario. Okay, now this one I left for a day by itself because it's a little bit trickier. We're going to solve systems of equations when neither of the equations are solved for y. Okay, so I will show you what that looks like. So you can see that both of these equations here, neither one of them are solved for y or solved for x. So we need to solve one of the equations for x or y to start with. Okay, and it really doesn't matter which variable you choose. Now I'm going to tell you why I'm going to choose this first equation. Okay, now I'm going to choose the first equation and I'm going to solve for x. Okay, because x does not have a coefficient on it. So it will be very easy to solve that for x. So x minus 7y equals 5. And we want to get the x all by itself. So that means I just have to add 7y to both sides. So I have x equals 5 plus 7y. Now that's really nice once we have that, because now if this is what x equals, I can take that and I can substitute it in here, right into here for x. Okay, so now I'm going to rewrite this second equation as negative 7 times 5 plus 7y plus 7y equals 7. And then we're going to go through and solve that equation, okay? So we use the distributive property first. So we have negative 35 plus negative 49y plus 7y equals 7. And then we can combine like terms. So we have negative 35 plus negative 42y equals 7. Okay, now I can add 35 to both sides to finish solving this. And we have negative 42y equals 42, and then divide by negative 42. So y equals negative 1. Okay, now we're going to take y equals negative 1 and I'm going to put it back into the first equation and solve it. So I'm going to take that first equation, x minus 7 times negative 1, since y is negative 1, should equal 5. X minus negative 7 equals 5. Well, really that's x plus 7, right? And then we're going to subtract 7 from both sides, and we have x equals negative 2. So the ordered pair, or the solution to this system of equations, is negative 2, negative 1. Okay, and we can check that that works. If the x is negative 2 and y is negative 1, so we have negative 2 minus negative 7, and then we change that, so negative 2 plus 7 is 5, so it works there. I can check the second one, and I can put those numbers in here. So this is positive 14 plus negative 7, which is 7. So my ordered pair of negative 2, negative 1 works. Okay? All right, so let's try, oh, I don't know what's happening there. Let's try another one just to make sure we kind of got this. Okay, here's another one where I'm going to solve for x again. I like to choose x if it does not have a coefficient on it. So I'm going to take this first equation and I'm going to solve for x. Okay, so we have x plus 4y equals negative 24. I'm going to subtract 4y from both sides. And we have x equals negative 24 minus 4y. Okay, now we take that and we're going to substitute that in for x to this second equation. So we put it right into there. Okay, because x equals that, we can substitute it for x. So we have negative 5, and then in parentheses, negative 24 minus 4y plus 3y equals negative 18. Okay, we distribute first. We have to do negative 5 times negative 24. And let me grab my calculator. 24 times 5 is 120. Since they're both negative, it's positive. So 120. We have negative 5 times negative 4y, so that's positive 20y plus 3y equals negative 18. Okay, we combine like terms. 120 plus 23y equals negative 18. Subtract 120 from both sides, and you end up with 23y equals negative 138. And then you finish solving by dividing by 23. Okay, and so I'm going to use my calculator to help me there. 138 divided by 23 ends up being 6, but don't forget the negative sign. So we have y equals negative 6. Okay, we have one more step to go because we don't know what x is yet. So we go back to the first equation. X plus 4 times negative 6, since y is negative 6, equals negative 24. X plus negative 24 equals negative 24. And then we're going to add 24 to both sides to get rid of the negative 24. And we get x equals 0. And it's okay to get 0 for an answer. So our ordered pair is x equals 0, y equals negative 6. So there is our answer. And I like to always go back and just make sure that it works. If x is 0 and y is negative 6, we have 0 plus negative 24, which is negative 24, so that one works. If x is 0 and y is negative 6 in the second equation, we have 0 plus negative 18, which is negative 18. So again, it works in both scenarios, okay? Let's look at one more. The last two, it was the first equation that we always solved, and we had x. But this one, there's a negative sign there, and that's really a negative 1x. So I don't want to solve that equation for x or y, but I look at the second equation, and I can see that x here is by itself. So I'm going to solve this second equation. I'm going to solve that for x. Okay, so x plus 5y equals negative 15. Solving for x, we're going to subtract 5y from both sides, and we have x equals negative 15 minus 5y. Okay, now that we have that, and that's what x equals, we're going to take that and we're going to go to the first equation and substitute that in for x. Now you have to be careful here. Don't forget about the negative sign in front. So I have negative 1 times negative 15 minus 5y, that's in parentheses, plus 2y equals negative 6. I distribute the negative 1 to both items, so I have 15 plus 5y plus 2y equals negative 6. And we combine like terms, so we have 20y, I'm sorry, no we do not. 15 and 5y are not like terms. So let's try that again. We have 15 plus 7y equals negative 6. Okay, and then we can subtract 15 from both sides. So we have 7y equals negative 21, and divide by 7. So you end up with y equals negative 3. Okay, this time we're going to go back to the second equation and we're going to substitute that value in for y. So we have x plus 5 times negative 3 should equal negative 15. X plus negative 15 equals negative 15. And then we're going to add 15 to both sides. So x equals 0. Okay, that tells me that my ordered pair, or the answers, are 0, negative 3. So that should work in both problems. And again, go back and double check it. So we have negative 1 times 0 plus 2 times negative 3. Well, that's 0 plus negative 6, which is negative 6. And in the second one, we have 0 plus 5 times negative 3, which is negative 15. So that's 0 plus negative 15, which is negative 15. So our answer works. Okay. Your job on your homework is going to be solving just 2 problems. I'm just going to give you 2 like this, where you have to pick one equation or the other and solve it for x or y, and figure out the values of both x and y by substitution. Make sure you show your work. Again, it's only 2 problems to do, so hopefully it shouldn't take you too long. Do your very best. Reach out to me if you have questions. I am here to help. I know this is not easy, so I hope that you're not getting too frustrated. Please let me know if you are. We can take some more time with this and really scale it back a little bit more. So keep me posted on how you guys are doing. Have a wonderful day.